Okay, so last week what we did is we had a look at modulus and argument. I didn't do a video, so can you guys give me the that there as a complex number? 3 plus 5y. So we'll call that W. So W equals 3 plus 5i. Happy with that?
Yep.
How you got that was from the coordinates of that, like an x, y type coordinates from there. Okay. Last week we also had a look at what does that bar above the W mean?
Conjugate.
Conjugate. So what does that mean? What's the conjugate of W is?
3 minus 5y.
3 minus 5y. So that's down here somewhere. Down here. Happy with that?
Yep.
Okay. So that bar means conjugate. That bar means your conjugate. What we wanted to do last week was look at that there. Okay. Another way of looking at it, what I'm asking you to do is to look at the modulus or the length of W. Because this here is written in, who remembers how that's written? What form is that written in? Rectangular form, yeah. And there's another form of describing complex numbers, sort of like a vector form, sort of with a magnitude and a direction. In other words, a modulus, which is the length, an argument, which is our direction. Okay, so what is the length of W? How would you do that? Pythagoras' theorem, yeah. So you'll see there's my right angle triangle, written and drawn beautifully. So my base would be 3, my height would be 5. So basically what I'm asking you to do is to go, I want you to W. Pythagoras' theorem, which is this. So h squared is 3 squared plus 5 squared, which is 9 plus 25, which is, you can write down 24, 34, yep. Can that be simplified anyway? Not easily, anyway. So the modulus of W, therefore, is the square root of 34. That's the length of that complex number. Happy with that?
Is it plus or minus or
not? If you would take the square root of 34, it would be plus or minus, because we're talking about a direction. The direction is a positive, but just the modulus is 34. Oh, sorry, root 34. Happy with that? And then so all we needed to do next was to go, what's this angle just here? Because that's our direction. Okay, and again, it's just trigonometry. Okay, what we would do is go, that's 34. So it's written as the argument of W is, how can we find that? Yeah, how can we find the angle? So Katoa, yeah, trigonometry. Which one do we use from those that were here last week? Not tan, yeah, we don't use tan, we use sine and cosine. Yep. So we go the cosine, the arc cosine of the adjacent, 3, divided by the hypotenuse, which is root 34. And our calculator gives us an answer. Okay. Happy with that? What we also do is do the argument of W again and do the arc sine of that, which again is the opposite over the hypotenuse, which is root 34. And we'll get an answer. That answer is someone's putting it on their calculator. Eh? Tick tock, tick tock, tick tock, tick tock. Okay, so we got that. So both are 1.03.
Yeah.
Both are 1.03 radians. Do you remember why we do the cosine? What it does, if you do this one here, you could be either talking about this complex number or this one down here. Okay, so because it basically tells you the real component of that, okay, the real component of that, and because our arguments always go from the real axis over to there, or there, the arguments are always between 0 and, arguments are always between negative pi and pi, okay? What should be the argument of x is always between negative pi and pi. So that, doing the arc cosine of that tells us if it's in this part of the real numbers or that part of the real numbers. Why do we do the sine? Because a sine of this one could be either up here or up there. Okay, it tells us if the imaginary part is positive or the imaginary part is negative. Okay, so that's what that part there tells us. It talks about the imaginary part. That spells imaginary. Please just believe me, it does. Any questions with that? It doesn't actually, though, just because. Happy with those? Any questions?